let's try another example. So now you have a diagram showing a plank weighing 120 Newton, supported by two triangles or trestles. The point X and Y have, this is the points where they have the pivots. And the man is weighing 480 Newtons. This man here is weighing 480 Newtons. Standing on the plank, calculate the total clockwise moment about point X. Okay, so now we need to calculate the total clockwise moment at point X. So if we look at the question, first we need to look at different points first and locate point X. This is our point X here. Relative to this point, we need to find all the clockwise moments. Okay, so is this, go ahead.
Shouldn't X be an anti-clockwise moment?
X is just a point here. There is no, this force applied on X is not gonna cause rotation when we take moment around X, because there is no distance from point X. Like, there's our point X and this is the force. There is no perpendicular distance. This is vertical distance. There is no perpendicular distance. We are exactly at the same point.
Okay.
You get my explanation,
Yeah.
right? Okay, so now what is the moment that will be caused by other forces? This definitely will cause a moment because it has some perpendicular distance here. And the rotation is gonna be clockwise because it's going to rotate this around the pivot in clockwise rotation. And then the 120 as well will cause clockwise rotation. Now the Y is pushing up. So pushing up around the same pivot, which is point X here, this will actually cause counterclockwise rotation, right?
Yes.
Yeah. So if I use the red marker, we can say this we have to calculate, this we have to calculate, this one we don't have to calculate for now. And also this part we don't care about because it's not going into affect our clockwise moment. Yeah. Now let's pick one by one first. So let's take the 480 Newton, call it moment 1, and then we need to multiply the force by the distance. So what is our force? It's already like given 480, right? Now you need to multiply it by the distance. Distance is also given. It's 1 meter to this center of the force. So you just multiply 1 by that number and then you get your moment here. Moment number 2 is the 120. So you need to multiply the force by the distance, and then instead of 1 meter you can use 2 meters because this is the distance to your force. So you can say 120 multiply 2 meter. Now you know this is gonna be 480 Newton meter. This will be 200,
240.
yes, 240 Newton meter. Now all you have to do to find the total, you just need to sum M1 and M2. Now you can get your answer. So it should be 720. 720. Okay, that's it. Basically, this question is done. Now let's move to the next part. In the same diagram below, a man weighs 400 on the plank. Use the principle of moments to calculate the upward force from point Y here. So now we need to calculate the upward force Y that we don't know. This is an unknown. Yeah. So now we need to find the force Y first, and then we can use the moment principle to find the force Y. Yeah. So remember we said if this is in equilibrium, we can say that the moment clockwise and moment anti-clockwise is equal. So right now we found this clockwise moment to be 720 newtons, right?
Yes.
Okay, so now we can say they are equal because this beam is balanced or in equilibrium. So it's 720 here and 720 in the anticlockwise. If we take moment about x as our pivot, we said that this y will cause anticlockwise moment, right? And it's
Yeah.
actually, yeah, actually it's the only anticlockwise moment. So we can say that the anticlockwise moment or anticlockwise rotation is gonna be equal to the force at y multiplied by the distance to the pivot. So the distance is 2 meter plus another 2 meters. So total 4. Now this we have from the previous question. So now we can just solve for Fy and say that 720 divided by 4 will be the answer.
180.
Okay. Do you guys understand how we
Yes.
got the answer? Okay, very good. Now, in the same diagram, the man standing on the plank again, what is the total downward force on x and y? Okay, so now we need to find the total forces, one at x and one at y. We already found y. Now we need to find the one at x here. Okay. So before we do the calculation, we need to know the rule. We said that the sum of all forces,
are equal.
yeah, are equal or equal to zero, like they are balanced. Okay, so sum of all the forces are equal. So let's say we have this force, we can call it maybe Fw because it's due to the weight of the person, and that one is maybe Fp because it's the weight of the plank, maybe Fp, and this is Fx, and this is Fy. Okay, we have all of them except one. So now we need to make sure we sum them in the same direction. This is going down. So let's say going down as negative force and going down as a negative force. Going up is a positive force. And Fx, we don't know if it's positive or negative. It can be either. So we don't know actually. Yeah. So for now, we will say that the up forces upward should be equal to the downward. Yeah. Or the sum of all forces. I think this is how you write the sum in mathematics. So yeah, in mathematics and physics, the sum of all forces it should be equal to zero. Okay. So what are all the forces that we have? We have the Fy, so sum Fy equal to zero, and then the sum Fy is this. This was 100 and what? Sorry, 180. 180 going up, so we say plus, and then the other two we say minus 80 for 80 Newton, and then minus uh, the other one is 120, and then lastly we have to add the fx. So we need to add the fx assuming it's positive. So fx, all of those should equal to zero. So now if we substitute, so we move everything to one side and simplify. So can you guys add 180 minus 480 plus 120? Should be minus, yeah. So
Minus 420.
so this to this and this should give us 300, right? And then negative 300 and then minus 120. So 420, yeah?
Yes.
Okay, very good. Now if you move it to the other side, you can say that fx is positive 420 newtons going up. Okay, yeah,
Yeah.
okay. So we got fx, we got fy,
Now we add
and
them.
then w- yeah, we can explain that these two forces are supporting the beam. You don't really need to add them because they are not at the same point. So just specify this and this separately. This is 180 and the other one is 420.
So we just draw them in the diagram in the exam.
Yeah, just specify fx, it means force at x, and fy means force at y. 120, sorry, 180 and 420.
Yeah, there are different points, I understand, but it says what
Yeah.
is the total downward force on both x and y. So would we lose a mark if we added them?
Mm, the total downward force, because you can see x and y are going up actually. So the total downward force, if we want to define what is the total downward force, then you need to just sum the 480 and 120. The total downward force is the sum of the forces going in the downward direction, which is just 480 plus 120.
Oh, okay.
Yeah. So basically, should it should be 600 Newton. But it's not applied directly. Like it's, yes, it's applied on x and y, but we don't know how much is taken by y and how much is taken by x. So I think you can write fx and fy. If they ask about total downward force, you can just say it's 600 newtons in total going downwards.
Okay. But would that
And
still count? Because it's saying at point x and y, and that's not necessarily
oh,
at point x
I
and y.
think the question phrasing is not so
Yeah.
clear. So that's why I calculated fx alone, fy alone. And now if you want to say what is the total downward force, you can say it's 600 Newton. If you also want to say what is the total upward force, it should be the same. So total upward is the same, but then we want to split it between x and y. So we need to know what is the value. One is carrying more, so x carry more 420, then y carries just 180.
Okay.
Yeah. If I want maybe to explain this to you just for your like FYI, your general knowledge. If you guys look at this diagram, we can agree that x here and y are at equal distance from the midpoint, right?
Yes.
2 meter and 2 meter, yeah?
Yes.
Why is the fx greater than the fy? Do you know why? They are at the same distance, right? From the midpoint.
Is it because it has a greater downward force?
Yeah, because if this is our midline or the symmetry line where the structure or the plank is symmetrical, right?
Yeah.
So we can say that the 120 is split between the right side and the left side equally, right? Because it's exactly at the midpoint.
Yeah.
But then the 480 Newton is mostly carried by this Fx force, yeah, because it's on so close to the x compared to the y, yeah. So by right, the x force should be greater than the y force, yeah, because the y is supporting half of the 120 and some amount of the 480, but most of the 480 is carried by the x. Yeah, is it clear?
Yeah, it's clear.
Okay, very good. Okay, so now that question basically we kind of answered right now. So they want the upward force at x, and we already found it to be 400, I think, and 20. Yeah, 420. So we don't really need to calculate it again because we did the working here. So we just need to write the answer at this point. Now in the diagram below, we have the plank again weighing 120. A man is standing the same position. The man now walks past X towards the left hand end of the plank. What is the upward force from the trestle Y at the instant the plank starts to tip? Okay. So from what I understood right now, they say that this man started walking into the end of the plank to the left hand side here, passing point X when he passed point X here. So he passed this point, and then what is the upward force at Y before the plank starts to tip over, before it fails? I mean, before it loses its balance or its equilibrium. Okay. So we need to make a new calculation. By now, the new position of this man here is probably somewhere in this point. We don't actually know. This is an unknown. We don't really know. Okay. So for now, we need to apply the same principle of equilibrium, but with a new position. So I'm gonna take this diagram here. Sorry, and then we can say our y is applied here. This is our fy, still in the same spot. The 120 is exactly in the middle as well. This is our 120. This is 2 meters. And the distance to x is still 2 meters. So this is our x, 2 meters. And the new weight, the 120, is basically applied somewhere here, downwards, as 120. And we know that this force is here, our fx. Fx. Okay, so what is the new direction of rotation? If we look at the 120, if we pivot it around x again, it's gonna rotate like that.
Anti-clockwise.
Yeah, anti-clockwise. And then we're gonna take moment around fx, yeah? So we said that this doesn't matter, and there is no more 120, sorry, no, this is the weight from the plank. Oh, what, the weight of the man was given before or no? Oh, the weight of the man is 480. Sorry, I forgot. Yeah, sorry. The weight of the man is 480. I confused myself. So the 120 stays in the middle here. Yeah. Sorry. I hope you guys keeping track. Are you lost right now?
No, but I was just confused about the 480 and 420, just like you. But
Yeah,
no, it makes sense.
So 480 is the weight of the
And
person.
420 is the
Now
force that we calculated.
yeah. So the 120 will still cause moment, and we can say it's clockwise because this is still our pivot here. Okay, and now the last force, we said it's an upward force, y, and then it will cause counterclockwise around our pivot. Sorry, anti-clockwise. Okay. Now we need to just simplify everything and say that clockwise and anti-clockwise will be equal, like we said before. So the moment clockwise will be equal to moment anti-clockwise. And the moment clockwise, what is the moment clockwise? It is gonna be the 120 multiplied distance to the pivot, right?
Yeah.
Yeah, so now we can take the distance to the pivot. It's 2 multiply 120. 408, sorry, yeah, 240 Newton meter. Now, when we talk about moment anti-clockwise, it's the sum between the Fy and also the other force due to the weight of the person here. So we need to sum. So I'm gonna say the moment anti-clockwise is equal to, first, the moment due to the weight of the person, 480, multiplied by x, or the distance to the pivot, which we don't know here, and then plus the Fy, which I forgot the value for. Oh, Fy is actually unknown because we need to find it, yeah. Fy is not given, it's an unknown, multiplied by the distance, which is 4 meters.
Isn't FY 180?
No, because now we changed the position of the
Oh,
person, so it will
okay.
change the Fy value. And yeah, they are asking what is the upward force Fy. So we have two unknowns, but we know that we can balance the this and that, and then we can put the 240 here. Yeah, and then this distance we don't know, so it's equal to 400 multiplied by, let's call it x, we don't know the distance x. Towards x and the, is it, does this in the question mean that the person is gonna be standing exactly at x or a bit far from x? Because I don't understand now. The man now walks past x towards the left hand. Okay, now that means it's exactly here,
Yeah, exactly.
somewhere here. Okay, yeah, okay, and then Fy and okay, I will try to answer it, no problem. So 4y, because we multiplied by the distance. Now we got this equation. It has two unknowns, so we cannot solve unless we find one of them, yeah? Now let's talk about the rest, which we said the sum of all forces, the upward forces and the downward forces, equal to 0. So now we need to define what are the upward forces and what is the downward forces. Yesterday we were doing this question with the person standing on the plank, and then if you guys still remember, the person moved from the center here, he moved to the left of the plank somewhere after x, so somewhere in the left hand side of the plank here. And then we were trying to first find what is the upward force at y. Yeah. So we need to solve it using two equations, two simultaneous equations, and then substitute one into the other, okay? I told you we need to take moment around x first, which we did. So we did moment around x, and when we did that, we got this equation, yeah? When we take moment around x, you can find that we will find Fy, but we cannot find Fx because there is no there's no perpendicular distance here, yeah? So x will not give you any moment, but y will give because there is a perpendicular distance from point x here all the way to the force at y. Okay, so this is our first equation. And then I told you we need to do the second equation where we need to find the moment about y. So this time we need to take moment about y. I just did it a few moments ago. So we choose y to be our pivot. This is our pivot. And then we take moment around y and we count. As we said, there is no perpendicular distance to Fy, so there is no moment because of Fy. There is the 120 Newton here going because of the weight of the plank itself. So that force is applying perpendicular force on the plank 2 meters away from our pivot. So it's gonna be 120 multiplied by 2. And then we move to the left side, and then we see Fx, this is our support pushing up, so Fx pushing up, and then we take the distance from Fx all the way to the support or the pivot, so the distances should be 4 meters. So now, as we said, we can take Fx, Fx is gonna be 4 multiply Fx, and the rotation 120 is gonna cause anti-clockwise. Fx will cause clockwise, right? Yeah? Do you guys see that?
Yes.
Okay, so Fx is gonna push clockwise, 120 anti-clockwise. Now, last force is the 480. It was going down in the example because of the weight of the person. Now we just shifted towards the left side of the plank, going down, and then we need to measure the distance from this point all the way to our pivot, which is going to be distance x from the point here and 4 meter from this point. So we can say it's 4 meter plus the distance that we don't know, we can call it x. Okay, and we need to sum all the moment and make sure the clockwise and anti-clockwise give us 0 or they are balanced. So I put negative for the force that going in the clockwise rotation here. And the other two are positive, yeah? The other two are positive. So now we just need to expand. 120 multiplied 2 is 240. 480 multiply 4. And 480 multiply x. So I did this first, 480 multiply x. And then 480 multiply 4. You can check on your calculator, should be 1920. Now we need to simplify everything. So simplify, you can add the numbers together. These two can be added. And then you get 2160 for the number. And x stays the same, 480x. And for fx, we can move it to the other side to be positive here. Then we can divide everything by 4. So divide this by 4. Divide this by 4. You get it simplified as this answer here. And this could be and should be your equation number 2. Now we have 1 and 2. So this is our first equation. This is our second equation. But the problem is we have one representing fx and fy. So we need another equation that mix fx and fy in the same formula. And yesterday we said that the sum of fy and fx should be equal to 600. So now we can just rearrange it. So if I rearrange it, I can make the fy the subject and say that fy is equal 600 minus fx. Okay, now I can plug, instead of using fy, I can plug my 600 and minus fx into the formula here. So I keep everything the same, but I can simplify it as well. So I can divide everything by 4 first. Divide by 4. Divide by 4. And then I get 240 divided by 4 is 60. 400 divided by 4 is 100. Yeah, so 100. And then fy divided by 4 is just here. This is 1. And then I need to substitute 600 minus fx instead of fy. Yeah. So this is my new fy. You guys are keeping with me, yeah?
Yes.
Okay. So now this is our new improved formula number 1. It has fx inside. This is our new f1. Sorry, formula 1. If I take these two simultaneous equation, I have one unknown. Sorry, I have two unknowns, fx and x, and I can solve for x and I can solve for fx. So just basically simplification. If you want, you can take the fx, plug it here, yeah, and then solve using your calculator. So once you substitute, you will have the 60 is the same. So I just put it here on the side, 60. 100x stays the same. Now the difference is instead of putting so 600 stays the same. Instead of using fx, I have to use this instead. So I put my negative sign in the front. I substitute fx, 120x here. I substitute the other number, negative 540. And now after that, we simplify it, divide everything by, I think, 4. And then after that, you substitute for, solve for x, move the x to the other side, divide everything by negative 20. So they cancel the negative sign. And then you should get 4 meter as your final answer. So that means that the weight of the person will be applied 4 meter from the support. Okay, clear?
Yes.
Is it too much? Did you miss out any steps?
Yeah, could you repeat?
Yes, a little
Yes,
bit.
Mari, it's a bit hard, right? Okay. you understand that you need to take moment two times, one time at x, one time at y? Yes?
Yes.
Teacher, are these type of questions gonna come in the exam?
This is a bit too much. I will show you the final exam kind of question today. This is more advanced because you need to solve many simultaneous equation and also take moment around two different points. This is a bit much, like too much for your level. So this is the hardest question that you can get almost in the exam. Okay, so this is not really realistic to have in your final, but it's a good way to know how to take moment around different points, solving simultaneous equation. Do you guys learn how to solve simultaneous equation in math?
Yeah.
Okay, so you know how to substitute. When I say fx is this equal to this number, then you know you can, instead of you using fx, you can take that and substitute in the equation and solve for x, right? You know how to do this, right?
Yes. Yes.
Okay, so the concept itself you understand from your math and physics, but it's a bit difficult to apply, so I don't think it will come in the exam. It will be a bit easier. Yeah, this is too much. Okay, so I will show you more simple questions today. If you have issues, we can repeat and discuss more on how to take moment around different points, because you need to know how to take moment around any point about x, about y. You need to choose the point and know which force is gonna go clockwise, which force is gonna go anti-clockwise. You need to know how to do this kind of steps. Okay.
Okay.
Okay. Let me move to the next slide. It's the same question still. So now we already know the person is moving to the left, standing to the left of the plank. And then we said it's gonna be moving 4 meter to this side, yeah. And actually the question here, it wasn't asking about 4 meter, it was asking you about the force at y. So by getting the 4 meter, you just need to plug it in here and find fx. And if you find fx, you can plug fx here and find fy, right?
Yes.
Okay, do you guys know how to solve this? Can you try to find the answer for fx using your calculator? So all you have to do is put x as 4 and then find fx. Let's try to find the value for fx. So maybe you need to multiply this by 4, then it becomes 400, and then 400 plus 600 is 1000. Move the 600 to the other side minus the 60. Sorry, the 1000 to the other side minus the 60. What do you get total? It's 940, right? I think.
Is that yellow line a 1? So
Yeah,
it's
yeah.
100. Oh, okay.
This is a 1, yeah. This is just a 1. You don't have to write it. What do you get for fx?
Yeah, I also got 940.
Okay, good. Okay, very good. So now we say that the fx is going up positive direction 940. Now what is the y? Y will be a negative value. So 600 minus 940 gives you three. Is it 340? Negative 340?
Yeah, negative
Yeah.
340.
So negative means it's
Yeah.
going down, yeah? Okay, I want you to visualize this, but I'm running out of colors. Honestly, it's a lot of sketching. I hope you're not confused. if you look at our plank right now, we said y is going down with 340.
Yeah.
Yes, at point y here. Then we have 120 going down 2 meters away. And then another 2 meters, we have the fx going up by 940. And then this one is going down at 4 meters by 480. Okay, so I'm gonna try to explain. First, you know that we have one force here trying really hard to rotate everything uh,
Yeah.
anti-clockwise.
Anti-clockwise.
Yeah, it's very good. Okay, you guys are keeping with me, so I hope the colors are helping you understand. So yeah, this point is going anti-clockwise. Yeah. Now, the second point, which is x is trying to counter that, right?
Yeah.
X, yeah. So x is trying to go the other way around, and it's trying to go clockwise. Yeah, clockwise. And now the other one is this force. If we compare it to this point, yeah, this force is trying to spin back at counterclockwise, anti-clockwise, right?
Yes.
Because this is our pivot, yeah.
Mhm.
Okay. So if you look, that's why you can see that the X force is really large because it's trying to balance two forces by itself. The 120 trying to go anti-clockwise and the 480. Yeah, that's why the X is really high. Yeah.
Yeah.
Okay. So you understand
Yes.
why the difference in values is really big.
Yes.
Okay. And the calculation for you is understandable right now.
Yes. It's clear.
Okay, so the 4 meter we actually got from the simultaneous equations. This question basically is solved as well. How far is it from the x point to the left? It's already 4 meters left of x. So somewhere here, this is 4 meters. And then we can say that the 480 is applied somewhere here. Also, this is solved. Now, this question is similar. I think now we can do it, like I'll let you guys do it with me right now, and maybe one of you will explain so that we test your understanding right now. Yeah, there's no need for me to do it myself. I can ask you to find, they want you to take moment around point x, and the result are total clockwise moment and anti-clockwise moment are the same, which is 3.2 Newton meter. Calculate the moment again from point y. Okay, so the question explained to you that they took moment around or about point x here, made it the pivot, and then after that they got the moment for clockwise and anti-clockwise to be 3.2 Newton meter, which means it's balanced. And then they want you to repeat the same steps, uh, calculate the moment again from point y. So now you want to repeat the same step from point y here. Okay, and then show if the sum of the clockwise and anti-clockwise moments still equal. Okay, so who can help with this question? Okay, go ahead. If you raise your hand, just directly
Yes,
start answering.
we have to calculate the distance from y to the point where it is 3 Newton. And
Okay, so now how many forces you need to do when you take moment around y? You need the 4, right? 4 is gonna cause some rotation or turning. The 2 and the 9
and 3.
and the 3. Okay. So now you need to take the distance first to the nearest force. Let's take it from here to here, yeah?
Yes.
So if you, yeah, go ahead, Muawiyah.
So multiply 4 by 0.2.
Okay, I'll call it moment 1. This is our first moment for now. So moment 1 will be equal to 4 multiply 0.2. And for the direction of that moment, because moment is a vector, what is the direction?
Clockwise.
Okay, so you're saying it's going to rotate like that. It's clockwise indeed. Yes, correct. Now, second point, we need to find the next force. It's going to be either the 9 or the 2. So you can choose.
The 2.
Okay, let's take the 2 to multiply the distance to the point. You
Is
can add.
0.3 meters.
You are always measuring the distance from your pivot. This is your pivot. So what is the distance from the pivot to your force?
0.3. No, 0.5. I'm sorry.
Yeah, 0.5. Now, when you take the direction, it's the same direction or a different direction than the force that we just
Same.
got. Same, right?
Clockwise. Yes.
Clockwise. Okay. Very good. So this one is clockwise and the second one is clockwise. What about the 9 Newton?
9 Newton. It is times 5. 9 times
Mm,
5, and it is anti-clockwise.
yeah, correct. Okay. Anti-clockwise. Okay, very good. So now next, the last
So
force.
3. Yeah. 3 Newton. It is clockwise, and it is 5, 4, 9, 0.9 meters times 0.9.
Okay, so 0.9, correct. Okay, 0.9 multiplied by 3. Okay. Now we know that this one is gonna be clockwise or anti-clockwise.
This one is clockwise.
Yeah. So if you sum all the clockwise, you have 1, 2, and 3. Is it gonna be equal to the anti-clockwise?
One second.
And sum for me. So I want you to sum moment in the clockwise, which is the sum between M1, M2, and M3, and tell me the answer. Sorry, yeah.
Two point 3.7.
2.
0.37.
Teacher, what do we have to tell you?
You have to sum M1, M2, and M3. So multiply this by 4. Multiply. You have to find the values. Sum all of them.
Yeah, I got 4.5.
8.1.
Yeah, they're equal.
I got 4.5.
Same.
Yeah, correct. So I don't know why. I think Nada said 2.37. Is it the?
I did 1, 2, and 4, not by 3. That's why.
Okay. So now the answer should be 4.5
Yes.
actually. And this is Newton meter, sorry. Not Newton meter. Yeah, Newton meter, not, I don't know why I put K here. Newton meter. Newton meter, this is 4.5. And then if you take the moment anti-clockwise, it's gonna be the same, right? Because 9 multiplied 0.5 should give you also 4.5. Right?
Yeah.
They are equal, yeah?
Yes.
So they are
Yes.
equal, and then you can say that the beam is balanced, and when you sum, you get the same value for clockwise and anti-clockwise. Any question?
No.
Yeah. How is 2 newtons clockwise?
2 Newton clockwise, okay. 2 Newton is here, and then this is our pivot, okay. So basically, your pivot is this point, and then the 2 Newton is pushing down here. So if you rotate like a clock, this is how your clock would rotate, right?
Yeah. Oh, okay. I see.
Yeah, so that would be clockwise, yeah. And then that's all okay for this slide. Let's move to the next one.
Teacher, I have a question.
Yeah, sure.
How's the 4 clockwise?
The 4, actually, 4 is the same concept actually. Okay. I'll tell you how we can help with this. Clockwise. Sorry, clockwise. Okay. I will show you. It's the same movement of the clock. Uh, maybe this one. This one is the best. This one is anti-clockwise. Wow. Okay, let's see clockwise. Okay, this is our clock. Okay, this is our clock. Yeah. Yeah, you see how the clock arrow is moving? This is clockwise. Okay. Need to paste it down here first. I will play my animation. This is our reference for clockwise, yeah? Do we all agree that this clock is basically going into clockwise?
Yes.
Okay. So now if I trace the motion of the arrow or the hand of the clock, it's going like this. Yeah, it's going from top down, spinning all the way clockwise. If you take the 4, if you take the 2, it's the same. So if this is 2 Newton, it's gonna push down. And I assume since this is the pivot, I'm gonna move this plank down by this angle when I'm pushing by 2. If I push it by 4, maybe I will push it double the distance, so it will move down to here due to the 4. So you can see if I keep making this pattern going from the 2 to here, this is clockwise. If I go from here all the way to here by 4, this is still clockwise. Yeah, we agree?
Yes.
Is it clear
Yes.
for everybody?
I have a question.
Yes.
Yeah, if you have a question,
Yeah,
ask
so
again.
for
Yeah.
the force, if it was a downward force, that means it will go clockwise and vice versa. Like if it was an upward force, then it would be anti-clockwise. Or does it
No,
depend?
no, there is no rule. It depends on where is your pivot point. Um, like the pivot has to be a point. See the clock itself? The clock has a pivot around this center here. Yeah. So if the force is going down here,
Yeah.
then it will cause clockwise. Yeah. If you have another pivot, if I change my pivot, so now I give you the pivot on this side. Okay. Now you see the force is gonna go down, cause clockwise. Okay, now second case scenario, I give you the pivot on the other side, the force go down. Which way is it gonna go, clockwise or anti-clockwise?
Anti-clockwise.
Roba as well, do you
Yes.
agree this one is gonna go anti-clockwise? Because my pivot position changed, yeah? It was to the left of the force, now it's to the right of the force. Yeah, so the pivot changed, then we know that the direction of rotation will change. Okay, very good. We can do examples and then try to answer more questions and test your understanding. So here is another question. This is actually from the IGCSE exam. So this is exam level question. Yeah. You have a tourist vehicle parked at a game park. Two elephants are pushing against the vehicle. The two forces indicate uh, right angles to each other. Okay, so basically they are applied at right angles. And then in the space below, okay, so the first part of the question is resultant force question. I think you also need to practice some resultant forces. So how can you find the resultant force if you have two forces applied in two different directions? Yeah, like one is going horizontally, one is going vertically, one is going in the horizontal axis, and one is going in the vertical y-axis. How can we resolve that?
You subtract them.
We can do that if they are in the same direction, like if they are going in the same plane, like the x-axis, we can subtract or add them. So these two will add them. If one is going like this, one is going like that, then we can subtract them. If they are going in the y-axis alone, like that, subtract, and then like this, we will add. But now they are not going in the same direction or same plane. So we need to use the triangle method. Do you guys remember the triangle method?
Yeah, yeah, perfect.
Okay.
You can.
So how, Muawiyah, to do the triangle method?
So 6 multiply. Right?
Okay, so let's take one direction first. Okay, I push the car forward by 4. So I'm gonna draw my 4 Newton in this direction by 4 Newton. Okay, my arrow is here. Now I have to connect the tail of the arrow to the top of the next arrow. So what means is this is my arrowhead. When I want to connect the next force, I need to connect it tail to head. Yeah. So the tail is here of the next force. I put my tail on the head of the other arrow. So the tail of the arrow goes here, and then I sketch up by 6, and I draw my arrowhead here. So 6 Newton, or kilonewton, sorry. And this one as well, kilonewton. Now, what is the resultant force between these two? If you imagine, let's say I was a person standing here, okay? I want to walk 4 meters to the left and then walk 6 meters to the north and get to this destination here. I want to be here at this point. I want to be standing here. So which way should I go if I want to go directly without going horizontal and vertical? Like, how can I walk diagonally? Yeah.
You go diagonally.
From the head of 6 Newton and to the tail of 4 Newton.
Yeah, but I want to go diagonally without going horizontal and then vertical.
Yeah, we connect these dots and make a triangle.
Yeah. I can just connect and go in this direction here, and then it will be a new value. This value we don't know right now because this is the resultant force.
So you do Pythagoras.
Yes. Okay, so now in terms of the resultant force direction, do we know the direction? We know it's like that, slanted, and we need an angle for the direction. So we need the angle between the two forces here. Yes, do you have a question? Yes.
No, I was just putting the answer. I got 7.2.
Okay, 7.2 is good. Okay, so the answer, do you mind explaining how you got 7.2 just mathematically, like how to get that value here?
Yeah, 4 squared plus 6 squared and then square root 52.
Okay,
Which
so
gives
we
you
can
7.2.
say, yeah, the resultant force is equal to the horizontal force
Yeah.
squared plus the vertical force squared. And then when you get the answer, you take the square root of everything on the right side and then on the left side here. So what is the value? 7.2, right?
Yeah.
Anybody has an issue of how to solve these kind of question, how to square the number, how to get the square root of a number?
No.
No, but teacher, I have a question regarding drawing the triangle. Which line should we draw first? Like you drew 4 Newton's line first.
It doesn't matter. You can go, I will sketch it again with a different color. You can go 6 Newton up first, no problem. And then remember we connect tail to head, right? With the tail, yeah, here. And then now you have to go to, we are here. We want to go to this point, right? How can we go? We go in this direction. So you see the two lines are parallel. These two lines are parallel.
Yeah.
So it's a same line essentially. They go in the same plane and the same direction.
Okay, teacher.
Okay, very good. Now, if they ask you about the exact direction of that vertical line, the diagonal line, you need to know what is this angle here. Because you will say it's this much angle from horizontal, yeah? So who can find the angle? Like, it's not asked in the question, but you need to know how to get the angle. Yeah, go ahead, try to answer.
Okay, so we would use the tan rule. Well, not the tan rule, but we would use the tan function. And we would do tan inverse and then 6/4 to find the angle.
Okay. So if this is our angle, this is the opposite, right? O, right? Correct. And this side is the adjacent.
Yes.
And this is our hypotenuse, right?
Yeah, and we're trying to find the hypotenuse. I mean,
No,
the
we're
angle.
trying to the angle. So which two you will use with the tan rule?
6 and 4.
No, you can't because the tan rule is supposed to be sine rule is opposite over adjacent.
No, I'm
Right?
not using the
So-
tan rule. I was using just tan inverse.
Okay. So you want to get the
Yeah.
theta here, and you
Yeah,
want to
because
use
we
the
already have
opposite
2
over.
values, so we can find the angle easily.
Okay. So from here you put 6 and then take the inverse function
6
of
over
that.
4.
And yes, and then this should be 6/4.
which gives 56.3.
What is the 56.3?
Yeah.
Okay, very good. Now this is the angle, and then when you write the force, you can say the resultant force is 56.3 from the horizontal, yeah.
Yeah.
Okay, good. Now the same diagram from this angle here, we have an elephant pushing horizontally against a vehicle with a force of 11 Newton. This elephant is pushing here with a force of 11 kilonewton, sorry. And then the distance from the ground is given as 1.8 meters. Point M is the center of mass for the vehicle. And then they want us to calculate the moment about point A exerted by the elephant here. Okay, so now moment about A, this is point A. You guys see point A?
Yeah.
And
Yeah.
moment due to the elephant's exerting force. So who can solve this question? We need to finish it before the end of the class. So just maybe Ruba first, because you were challenged by the other question. Try to do this one. Hello, do you guys hear me?
Yeah.
Yes.
I don't hear it.
Okay, let's give it a shot. Like, let's try to find the moment because of the elephant about this point. So remember, when you want to find the moment, you need to find the force and the
Force
distance. So what is the force?
11 kilonewton?
Yes.
Kilonewton?
And then what is the distance?
1.8.
Yes, yes. But Ruba, do you understand why we take 1.8?
No. How?
Because the force is going like here horizontally, and then we need the perpendicular height. So that height is perpendicular to the force exactly, and it's at like the pivot is here and the force is here, and that's the distance we need.
Oh. I see. Yeah, I got it.
Okay, and now this is our point A. So I'm gonna sketch it here from the side. This is point A. This is our force, 11 kilonewton. What is the direction for this moment?
Well, it's negative.
Sorry?
It's negative because it's going to the left, right?
No, we're asking about clockwise, anti-clockwise. We don't.
Anti-clockwise?
Oh, Muawiyah, wait.
What's wrong?
Let Robas answer the question because she
Okay.
don't know. Wait, do you know if it's gonna go clockwise or anti-clockwise?
It's going to go clockwise.
Okay, so I'll bring the. You want me to bring the clock back and let's see if you're correct. Okay, this is clockwise, and we agreed this is clockwise. So now let's compare. If we push with the force, we said it's 11 kilonewton. This is our pivot point. This is our pivot. We are moving around the pivot. So when I move it by 11 Newton, this will probably shift a bit to this side and move in this direction.
So it's anti-clockwise.
Yes, exactly. So it's anti-clockwise because the clock is going like that, clockwise. Yeah. So now you said 1.8 multiplied by 11. So what is the answer? 88, right? Kilonewton meter. Yeah. And then the direction you can say between brackets anti-clockwise.